Hi, I'm Steve here in Santa Cruz, California, where I'm joined with Matt, who's a bicycle trick stunt artist. And hi, Matt.
Hi.
So tell me, do you solve problems while you're bicycle jumping?
That was definitely the way I ride. Is definitely some problem solving. Trying to figure out. I ride on the rocks out here on the jetty, and just trying to figure out where my wheels can go, where they're not going to slide and not going to get a flat and stuff like that, to make sure that I can stay on my wheels and not fall.
I understand you have an educational background.
Yeah, I got a degree in physics. It seems that this type of riding, most people that seem to do it kind of have math-oriented minds. I don't really know why that is, but it just seems like it's a thing that goes together. I think it has to do with the problem-solving side of it.
Okay, great. Do you mind doing some tricks for us?
Sure.
It's a core challenge. Whoa.
In the video, the bicyclist jumped from one pillar to another pillar, and those pillars, I'm going to estimate, were about 7 feet apart. Okay? He stood the bicycle up on one end and jumped it across using his momentum and his force on the pedals. Okay? Well, this is a physics problem, but this is a math video. So in order to do the physics problem, we needed to know the basic algebraic properties of solving an equation. And if you remember in middle school, what you first learned, the first multivariable equation you learned was probably something like the distance equals the rate times time. Okay, a rate probably being miles per hour times the time that you drove, and that equaled the distance. And then you were asked to find other variables here, like the r or the t, in terms of the variables. Okay, so if you wanted to find r, you would start with the d equals r times t, and in order to get the t over to the other side, you would do the opposite operation. Here it's a multiplication, r times t, so you would divide both sides by t. The t divided by t becomes a 1, so you're left with r is equal to d over t. And you do the same thing with t. If you're asked to find the t, you start with d equals r times t. You get the r over to the other side by dividing both sides by r. R divided by r is 1, so t is equal to d over r. And there you have the 3 different variations of this same equation. In the physics problem, one of the first formulas that you learn is force. And in this case, it's force equals mass times acceleration. Okay, this is mass, and this is acceleration. F, of course, is the force. So how much force was needed for the bicyclist to jump from one pillar to the next pillar? Well, let's make some assumptions and try to find out. The type of bicycle he used was a modified mountain bike. Mountain bikes could typically go maybe a maximum of 20 miles per hour. in order to go from here to here, he had to accelerate very, 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 very quickly. He never reached 20 miles per hour, but he probably used enough force to get to about half of that. So let's say 10 miles per hour. So let's use a figure of 10 to start with. The mass, we're going to have to estimate. I would estimate that his weight was about 180 pounds. The bicycle, probably a medium weight bicycle, so probably about 20 pounds. So a total mass of about 200 pounds. Okay? And using those two, we can find the force. 200 times 10 is going to be 2,000. And that would be the force needed by him pushing down on the pedals to get that bike across over there. So using the same properties of solving equations, you could also find for the m and solve for the acceleration if you knew two of the other factors. Okay? So wherever you look, you can always find mathematical problems in the world around you. Just stop, take a look at what's going on, and you're going to find math in pretty much everything you see. Have fun.